Yep, I see the PowerPoints.
Okay, so let's get started with just a kind of an analogy, a metaphor for what we want to be talking about during this hour. I noticed a few of you are from Canada or from the, Michigan, where logging is not unknown, and one of the most dangerous jobs in the world, actually, is the job of going out and trying to break up this thing here. In our live class, I asked students to give us the term for what you see in front of you, and that word, of course, is logjam. So you see a logjam in front of you. Now, what happens is upstream, people have been cutting trees, and then the trees are dragged down to the river, and then they float down the river to a mill, right? So presumably, there's some kind of way of grabbing them at the other end and dragging them out of the water, and then processing them at the mill. Now, if for whatever reason they get jammed up like this, then that log jam has to be broken up. And again, that was one of the most dangerous jobs. Is you have boots with spikes on them, and you got these long poles, and you walk out there on the logs and try to get things flowing again. So the analogy then to manufacturing is this: if you are building products, you're an operator, and you're doing work, and you have the equivalent of a logjam, which sometimes we call a bottleneck. In other words, things are not flowing. Maybe it's a material issue. It doesn't really matter what it is, but material issues are common, or it could be a quality issue or a machine breakdown. There, yeah, whole list of things that could be happening. So our question is, would it make sense? So what would you do? Would it make sense to just keep working, right? And adding more logs to the log jam, or in the factory, adding more WIP to the system when you have a place in that flow that's not flowing? Well, I think we could all agree the answer is no, right? Would not make sense. So then the follow-up.
Don't cut more logs and throw them in the river. Go down the river and help clear the logjam. That's the analogy, right?
Right. So that makes good sense. So the follow-up question, what would you do, is, well, stop working where you are, or stop cutting logs, and ideally go to where that jam is, or where the roadblock is, or the bottleneck is, and contribute to clearing it out, right? Getting it to flow again. So that's the analogy. So I think it's a pretty good one. And the term we're using for that is flexing. And we've kind of made the word flexible into a verb. So I flex, you flex, we flex, they flex. That's that in English, it's easy to conjugate those verbs, isn't it? It's all the same one. In Spanish, what would it be, Gerard? Yo flexeo?
No, that's...
Tu flexeas?
No.
That's just not right.
You're ruining the language.
That's just not right. Okay, so flexing means flexible employee, or a worker that can work in more than one place. So we're saying that as definition 1, so that implies we have definition 2 and 3 coming up. So flexing is an operational strategy by which operators or workers physically move, and work in the direction of a work blockage to facilitate product flow and productivity. So that direction could be, in the case of a river, it's always downstream, right? But in the case of a factory, there could be a blockage upstream, in which case you're not receiving anything, right? The river doesn't have any logs in it if you're on the downstream side of that blockage. And the two main benefits are, you're going to improve product flow, right? So your throughput is going to go up, and you're going to be more productive because you're able to add value more consistently for a longer period of time. So that percentage of value adding time goes up, right? Anything to add, Gerard?
Yeah, and there the key word is blockage. Wherever the blockage is, what is the reason why the product is not flowing? You move in that direction. And as we will see, moving in that direction is not done on the basis of opinion or on the basis of someone ordering you. It's done on the basis of signals. And that is a big part of what we're going to discuss today.
Okay, so a couple other quick definitions, similar. Oh, we have a visual animation here of someone moving, right?
Yeah.
That's really impressive.
Yeah.
Oh,
You do.
hey, moving to the work. Right. That's really helpful. Okay. Flexing definition 2.
Hey, I put it there. Must be.
Yeah. Okay. So another way of saying what we just said, operator flexing means to move and work upstream and downstream along the line to improve productivity in the flow of a product. Now, it could be sideways as well, I would imagine, right? It's not restricted to just working up or down. You could actually flex up into a feeder line, for example. That's an option. But basically, it means moving, being willing and able to move and work somewhere else where the work needs to be done. Another take on it is flexing takes place when operators respond to demand signals. So I think Gerard was just alluding to that a second ago, that it's not simply random moving around or looking for something to do or looking to make yourself useful. There are definite signals or rules related to how and when you move. Okay. So with that, I think we can move on and get into some of the details of how this would actually work. Now, the question here is, why would you want to do this? I mean, we understand the bottleneck idea, but why not just work where you are? Why not just stay where you are until things clear out, right? That would be an option. In fact, that's actually what happens at most places is if there's a blockage, you just take a little break, step back and relax a little bit, do a Sudoku puzzle and wait for things to start moving again.
Or start doing some work ahead, right? Build something that is done at the next workstation, or pile up some of your own work. That doesn't help. That opens the door to quality problems. And what you want to do is to have clear procedures at the line that you build, one for the workstation, one for the IPK, and no more.
Yeah, so staying at your station and keeping yourself productive by building WIP is something that's not actually allowed in a lean line. And so we're saying here there's little or no inventory between workstations or at the workstations. So basically, if you can't move a unit out of your station, then you're blocked. In fact, if you've ever had any experience with simulation modeling, that would be like a technical term, right? So there's a blocked flow. And the other side of the coin is you could be willing and able to work, but you got nothing to work on. So you're starved. So both of those conditions are going to happen much more quickly in a lean line than in an environment where you're allowed to just work there and pile up work in process inventory. Right? That's not something that we're allowing in a flow line or in a lean production environment. So it's important then, for that reason, that we take appropriate action, quickly if we find ourselves in that position. Okay, now we've defined 3 types or 3 levels of flexing, and they actually are levels in the sense that they are organized in order of increasing benefit or increasing impact. Starting with what we're calling overlap, and then workstation flexing, and then bumping technique or bumping flexing. So we're going to walk you through each of those 3 techniques and explain how they work. But understand that overlap is the least.
Yeah.
Go ahead.
And also level of complexity. Would you agree, Richard?
The
overlap to workstation to bumping, it gets a little more difficult, a little more complex.
Yeah, more training required, right? More coordination on the part of more initiative, maybe on the part of the operators.
Mm-hmm.
And we start with the simplest one, which is flexing level 1, overlap. So another term for overlap that we sometimes use is called aid and assist, like a little slogan that we use. And overlap works like this. So we've got, if you are blocked, so picture yourself at a workstation, and if you are blocked, then what you do is you move down. downstream in the direction of the customer. And what
So
you're going to do when you
here
move
means,
down,
I'm sorry, block here means you got ahead of the person next to you, the person downstream from you. You got ahead of that person. So it's very likely what happened here is that your IPK and your workstation are full. At that time, you stop or you flex. In which direction you flex? Downstream. That is what we already taught in class.
right? But the important point is that if this line is fully staffed, then when you move down, you're actually moving down to help someone else, as opposed to just taking over an empty station. And that's why we're calling it aiding and assisting. So the basic philosophy is pretty simple. It's, hey, if you don't have any work, or you can't work at your station because you're blocked, flex down in the direction of the blockage and see what you can do to help in that direction. And of course, you can also be moving up. So if you're starved, you're available to work at your station, you have no material to work on, no product, then you would do the same thing, but you'd move in the opposite direction. You'd move up to help, right? To aid and assist. Now, we're not saying that you can always do that, but aid and assist means helping your coworkers on either side of your station, so upstream or downstream. Okay, helping your coworkers to do that job to clear out the bottleneck or to improve the flow. Now, what you do to help needs to be thought through ahead of time. If you just show up, of course, if you just show up at a station and say, "What can I do to help?" Your coworker may be able to tell you something, but it would be much better to have a plan. So when you flex down or flex up, you have some idea of what it is you're going to do. And we're not saying that that's even always possible, right? To actually aid and assist. You could have, in fact, it's probably quite common, situations where you simply can't help. The person just needs to finish that cycle, finish their work, and there's nothing really you can do to help them. I remember one of the clients we had in Dallas was doing microprocessors, hybrids. And so this work was very detailed. It was done under a scope, and it was progressive work. But when you were working at your station, there was no way that anyone else could come in and help you because you were looking through that scope. You're doing very fine, detailed work. So we're not saying that aid and assist is always possible. But if it is, then you want to make sure you think this through ahead of time so you have some idea of what it is you can actually be doing that's not interfering with the person on the upstream or downstream side. Right? Anything else, Gerard, you want to add to that?
Yeah, this tends to be a very likely scenario for those of you building large products. We've seen this with trucks or tractors or forklifts, lawnmowers, products that allow for two people to work there. In a few occasions, so what we have seen is even if there isn't room for two people to work, we have achieved some gains in productivity when the second person comes in and becomes sort of an assistant, not a second operator, but an assistant, handing tools and handing parts to the primary operator. And think about what you're doing with this. You left a workstation. That means you decelerated that workstation. You came into another one, and now you're applying more resources. So you accelerated the other workstation. In that way, you will move the product faster, right, than its standard time, and then you will go back to your workstation.
Yeah, that's great. Helping with parts selection or tools selection, et cetera. That's something that's a great suggestion. But again, you think that through ahead of time. And if you simply cannot aid and assist, then you're going to have to wait. You have no choice. But obviously, if you're waiting, you're not adding value, and your productivity is going down. Right? It's not going up. So the thing is, this last bullet point simply means that when you do flex, when you do aid and assist, then some communication also is a hard requirement. In other words, your coworkers on the upstream and downstream side need to be communicating with you so they know you're there and they know that you're now working as a team. So that's clearly important. That's going to be important for the other steps as well, the other flexing techniques. Okay, so here's a graphical illustration of that. So we have 3 workstations. Those of you that have been to some of our other webinars know that the red X is an in-process Kanban, right, or buffer. And so we have 3 stations. We have 2 people here, Mr. Blue and Mr. Green, and we're building some products. As Gerard just mentioned, this is easier if you have a larger product where you can, have more than one person, maybe a person on each side, or you can get in. You have a little more space to get in there. So in this case, you can see that the blue station, workstation 1, has a unit in their in-process Kanban. They have another unit in front of them, and at that point, they are stopped. The blue worker is stopped, not allowed to start or work on a third unit. So instead of just waiting there, then that person is going to move over and aid and assist at workstation 2 until the unit is completed and can be moved out. And then when that happens, now workstation 2 is available to work on that IPK unit, and Mr. Blue can go back to workstation 1. And what would happen then, of course, is this backhoe is going to go into the IPK and a new unit can be started. So pretty simple, right? Not rocket science, but that's how it would work. Now, overlap, some important points.
Still,
yep.
Still, it's remarkable how little usage this technique gets. We are right now in the middle of this with a line design we're doing for a substantially large product, and these folks immediately said, "Oh yeah, we're doing this." When we show them their simulation model, I mean, the productivity gain is just noticeable. I think we are well above 15% gains for this line. This is a complex product, so we are living it right now.
Yeah. Okay, so important points, usually applicable to large products. I think we made that point earlier. Assumes a fully staffed line. So we're assuming that there is an operator at each station. If there wasn't an operator at each station, we're talking about these different flexing techniques that we're going to talk about next. But this assumes that you're moving up or down, but there's someone there at the upstream or downstream station. Someone already there, another operator is already there, and you're trying to help them. I think that's the main point we're trying to make here. Now, those of you that have not been to our classes or maybe heard some of our other webinars might be asking yourself, well, aren't all lines fully staffed? And the answer is not necessarily. It is kind of the most common scenario where you'd have if you have 5 workstations, you've got 5 workers, but it's not required, right, to do that. And we'll get into that in just a second. This is the smallest opportunity, if that's all you're doing is aiding and assisting, smallest opportunity for productivity gains, because you're probably not as productive aiding and assisting. You're helping, and so it's a positive, but we're talking about single-digit productivity gains for the most part, if this is the only thing that we're doing. All right. Anything else, Gerard, before we go on?
No, those are very accurate points. So yeah, let's move on to the next one.
All right. All right. So flexing level 2. So we're jumping up quite a lot to go to workstation flexing. And the little slogan that goes along with that is 1 up, 1 down. 1 up, 1 down, meaning an operator really needs to do flexing level 2. An operator needs to be trained and certified in more than one station to do this right. So minimum expectation to work in a workstation flexing environment would be a primary station where you spend most of your time, but you also are fully qualified, certified to work at the station downstream from where you are and the station upstream from where you are at a minimum, not a maximum. I mean, you can do a lot. You can do a lot more than that. Be more cross-trained than that. But that's something that we strive for, very diligently to make sure that every operator working there can cover at least 3 stations to make sure this technique will work. Mm-hmm. Okay, So how far, how much? Well, we start with cross-training in those three. I think I just made that point, right? So we have a primary station, your main or home station, one up and then one down workstations on either side. We don't want to just stop there. So the level of cross-training could be the entire cell, right? Or the entire line. It just depends on how practical that would be. If you have a short takt time environment, if you have a 60-second takt time, then learning many different stations is not a daunting task from a learning curve point of view. But if you have a 2-hour takt time and you're asking people to learn, even 2 extra stations, you're asking them to learn 4 more hours of work content. So it becomes harder and harder as the takt time gets longer and longer. But there's no hard and fast rule that says you need to limit yourself to the level of cross training. So I guess that's what I just said here. So function of a takt time is if you have a very short takt time, count on doing more than just one up and one down. But if you have a longer takt time, it just becomes a practical matter of training, right? Of learning. And there's just there will be a lot more steps to learn if you have a longer takt time, which just makes it harder. Not impossible, it just makes it harder. One thing we need to avoid in our line layout are barriers to moving, to flexing. So we have to be very careful when we're talking about conveyors or tracks, any kind of track that is hard to cross, or cranes, or the most common barrier would be how you're storing material. We don't want to make operators have to walk around large racks to get from one station to another. So this would be part of your line layout audit. If you have the opportunity to redesign or relay out a line, to really take a hard look at, are we making it easy for operators to move up and down the line and flex? If it's harder, then you have a couple challenges. One is it's going to take longer. So that downtime of moving, which is one of the Toyota 7 wastes, right? The waste of motion is going to be increased. And the other thing is, if it's too hard to move, then people are not going to do it, right? So they're going to be disincentivized to actually aid and assist or move in the line.
And you're going to see fewer people, or you're going to see more people waiting. When right. You don't flex, you wait. There is, in that productivity just goes down the drain. You never get it back.
Yep. Last point we're making is that you shouldn't have in your mind that if we're implementing flexing, that people are moving around all the time. The frequency with which people would have to move is really in direct proportion to the level of variability of the work content, both in terms of product work content variability and in terms of operator work content variability. So if the line is well balanced, meaning more or less the same amount of work content at each workstation, and people are well trained to work within that boundary, that time, then most of the time, an operator is going to be at their primary workstation. They're not going to be moving every cycle or far from it. In fact, if you did a simulation model and there was no variability in work time, then there wouldn't be any flexing, unless you had fewer operators than the number of stations. But work most of the time at your primary workstation is what happens.
Yeah, and having fewer operations than workstations, in many occasions, that is a very good approach because it increases your productivity. It forces the flexing. However, as Richard said, there is such a thing as too much flexing, and we will discuss that in a few minutes.
Yep. Okay, so here's our little graphic image, Mr. Blue and Mr. Green. Same kind of line. And you'll notice there's no operator at workstation 3. So let's go through and see how this would work. So we're building smaller product this time. Okay, workstation 1 is blocked, and workstation 2 is also blocked. How do I know that? Because there's a product in the downstream IPK for both of those two stations, and this hammer that you see at the station is a finished hammer. So that's an important point to make, that we allow a unit in the IPK and an additional unit completed at the workstation. But in this particular shot right now, those two operators are blocked. right? They're stopped. So now what do we do? Well, if there's no one at workstation 3, so we had an open station, then it's fairly straightforward that the green operator can just move down to that station. And that opens up the opportunity for Mr. Blue to flex down to workstation 2. Now, how does that help? Well, now the hammer can be pulled from the upstream IPK into workstation 3. And so Mr. Green can start working on that one. And then this hammer gets moved into the IPK. And then this next hammer gets moved in. Now Mr. Blue is able to work, right? So now we're adding value, okay? And if we just, I think that's it. So if we keep on going, we could have an extended animation, and these two people are going to be moving back, shifting back and forth based on the signals, either having nothing to work on or being blocked by units in the IPK. And they're going to be moving, shifting upstream and downstream based on those simple rules. So now we have 3 stations and 2 operators. Are we going to get the same output with 2 as we would with 3? Well, probably not. But maybe we don't need that level of output either. And we'll talk about that in just a couple minutes. The impact of variable staffing. But you can see the main point here is that if you have an empty station to move into, then Mr. Green and Mr. Blue can continue to work and continue to add value. And as long as you're working, then you're flowing. The only time you're not flowing is when they're not working, right? So if they're able to add value and able to do work, then that product is flowing. Okay, anything else, Gerard?
No, that's pretty much it.
All right, so important points about this workstation flexing. It does require the availability of open workstations. Otherwise, we're talking about aiding and assisting, right? So what we're saying here, and this is the, I don't know, what would you call it, Gerard? Kind of a culture shock for some people.
Yes, because it is part of how you design the line. You design the line to have more workstations than people. As a matter of fact, if you come to class, you will hear us talking about designing a line with holes in it, right? And that generates that forces the flexing. That increases productivity all by itself. But it requires the commitment. This is one higher level of commitment than our first level aiding and assisting.
And I think we have maybe a divergence between what we teach and the pure Toyota production system when we talk about open workstations, because I'm not 100% sure about this, but I don't think this is something, at least we've seen it at a place like Toyota, where they would actually have an open workstation by design. They might have it because it happens.
Yeah, a couple of things happen with Toyota. One of them is that they are masters of balancing, right? So they spend enormous amount of resources balancing. They balance to the nanosecond. That's one aspect of it. And then you have to remember that the product is large. There is room to help, and they have floaters. Yeah. The line leads flex into the line and support the line from the outside. The folks at Toyota put quite a few resources, indirect resources on supporting the line.
But I think the idea of designing a line with planning on having workstations and not having workers full time at those stations is probably not something that they do. Not something that they do. But anyway, so this is what we're suggesting. For the reason so another important point or aspect of this workstation flexing is that you move only at the end of a cycle, end of a takt time, let's say, end of a work cycle, not in the middle. So in other words, you complete your work on that unit at your station before you would contemplate moving upstream or downstream. And I'm mentioning that because when we get to level 3 of flexing, you actually don't do that. But in this case, you do. So you complete the work that's defined for that product and your station. Every unit that comes down the line that arrives at your station has standard work defined for that. The work steps have been predefined. Here are the work steps you're going to do here, and you have the parts and you have the tools to complete that work. And you're going to complete that work before you would think about moving upstream or downstream. Okay, so that's an important concept to keep in mind. And if you have quality checks, in other words, do your work, check your work, and then have the next person downstream double check your work. You have to keep in mind that if you're moving or flexing between stations, then those predefined quality checks may be impacted. In other words, you do work, you check your own work, and then you flex downstream and you pull the unit in, and there's a quality check defined, initially defined for ideally another person, a second set of eyes. But guess what? You're checking your own work twice. So that kind of level of checking your own work twice is going to happen, and you just need to be, as a line designer, you need to be aware of that and make sure that that's okay if it's happening periodically. In other words, could you check your work? Could you do a self-inspection of your work and not see a defect and then look again and see one? Sure, you could, but is that likely? It's not as likely, the answer is, than having a fresh set of eyes, take a look at it. So it's not ideal that you're checking your work twice, but it's unavoidable. If it is a critical issue, then it's going to need to be thought through. You may even have to have a different person come over and do that quality check at that station, if that's the case.
If you're checking an airframe, right, or you're checking the tronions on the wings on F-16, very likely here you're going to have to do what we call a call over quality check. Right? If I am checking myself, I may have to call somebody else. That would be a floater, supervisor, come in, check this. And that's a price you pay for productivity gain. And that's unavoidable.
Yeah.
It happens all the time, by the way. Remember, you stay at your workstation the majority of the time.
Correct.
Flexibility.
Yeah, one other comment too about quality checks, just from our experience at Toyota Material Handling in Columbus. They do not have quality inspectors on the manufacturing floor, manufacturing part of the factory. Now, they do plenty of inspection on the floor, but it's done by operators, right? The operators are checking their own work, their quality expectations. Now, once the unit, fork truck in this case, comes off the line, then it gets essentially turned over to the quality department that has their own set of checks and inspections and tests that they do. So it's not that they're never testing the unit, but while it's in manufacturing, the operators themselves are being asked or are required to check their own work, and that's what we're talking about here. Right? Yep. Do work and check your own work. Okay, so that's flexing technique number 2, and then we have the third level, which I'm calling bumping. And the slogan would be bump, don't jump. And this is maybe advanced flexing, might call it that. And it's actually pretty rare, and there are certain prerequisites for you to be able to use this. So
we have seen this done in very short takt time environments where it's also, for lack of a better term, easy to understand where you pick up the work. You take over for somebody else. The challenger is understanding where that person left it, right? So you walk into workstation and you literally bump that person, physically bump that person, of course, gently, but you take over for that.
Right. So similar in the sense that you're moving up and down a line based on the availability of work or being blocked for a series of work steps that are defined in front of you. However, if there's someone at the workstation or just downstream or upstream from where you're working, you're attempting to go into, then you don't aid and assist them, you bump them. In other words, you say, tap them on the shoulder, whatever the signal is, and you take over wherever they're at, wherever they're at in the cycle. Now, clearly that requires communication, and it requires an environment where that's even possible. But what you do basically is you ask them or they show you where they're at in the sequence, and you take over from there. And then that person, in turn, like a chain reaction, would move upstream or downstream. And so the entire line would be bumped or be shifting down or shifting up at any point, really. So bumping means taking someone's place as opposed to helping them. Right? You're not helping them. You're just taking over wherever they're at. The picture I have in my mind for this, maybe that would help, is instead of discrete workstations, imagine just for a process, a whole series of work steps with no workstation definition, but laid out as kind of a continual flow on one long table, let's say. And you've placed the materials along a timeline, more or less where that material, in terms of the elapsed time, is going to be needed, consumed. And you have enough space to fit more than the number of people working there. So there's room to move, right? Shift up and down. This sounds like it could be completely chaotic, and I suppose it could. But the point is, and this has been testified, and explained to me, that once the team gets how to do it, then it's very smooth, and it has the advantage of less downtime, less waiting time. Once people understand how this moves, this bumping process. In other words, people are able to add value a higher percentage of the time than if we did the workstation flexing or the aid and assist type of flexing. Okay, and for this to work, clearly the handoffs, where I take over from someone else's work, needs to be very clear and a very clean kind of handoff. So we're not telling you that this is always even possible. But if you can do something like this, then the potential gains are higher. So let's see how this would work in our little graphic scenario. So you notice I put these stations together a little bit closer to make it easier to. No IPKs. So we don't have any buffers. We don't need any buffers in this case. And there's hopefully less of a distance to move, right, if I have to move. And I would just go here, and that person would bump downstream. Now, if we had more than 3 stations, that whole chain would ripple down to the end and then ripple back up. It may sound, like I said a second ago, it may sound like a recipe for complete chaos, but as long as you have the right conditions, then it can be extremely productive.
Frankly, we don't implement this. We don't implement this. We are an assist and we are flexing guys. Bumping would not work on a really long line because that chain reaction is very unlikely to look like the wave at the stadium.
The football, the football game. Yeah.
Exactly. It would not happen that way. Now, on a small cell, 5, 6, 8 workstation, yes. When you start making this a long line, it's going to be difficult to get that level of coordination. But we invite you to take a look at the book where this is explained. It's not one of our books, by the way.
Yeah. I'll show you the book here in a second.
Yeah.
Now I had a interesting. I did a podcast. I think it's on our website, LeonardoGroupAmericas.com. Podcast with the author of this book that describes this technique. Gordon Guerin is his name, and one of the points he made to me too is that for this to work at all, it requires really great teamwork. And so what he's seen in his experience is that it's a great team building kind of work environment. Because you're coordinating with your coworkers a lot, right, in terms of who's doing what and where you're taking over. And so he thought that was extremely positive as well. And because you're not waiting to the end of a work cycle, it also, as I said a minute ago, has the greatest opportunity for productivity gains. And Gordon said that it would not be unusual to see, if you're going from a more traditional environment to this bumping environment, not unusual to see up to a 30% productivity gain, which is huge. right? Huge. So in terms of percent productivity gains, probably the first one, the aid and assist, single digits. The second one, workstation, double digits. And under the right conditions, this could be even higher than that. So companies report 30% productivity improvement. So that's pretty significant. So if you want to learn more about it, here's the book. Here's the author. You can listen to our podcast on our website. I believe it's under blogs on our website under the blog menu. But basics of self-balancing processes, true lean continuous flow. It was kind of funny in talking to him. He said he developed this technique, or he started doing it because based on what he'd read back in the earlier days of lean, he thought that's the way everyone was doing it. He thought that was the technique. That's how he understood it. And it was only until later that he realized that, hey, most people are not doing this, but it seemed to be a good thing. So you can find this book, anywhere fine books are sold, like Amazon. Okay. Now, one option for flexing, Gerard touched on this a minute ago. Why don't you talk about this, Gerard, the floater concept?
Yeah, sure. And this is something we do implement, the idea of a floater, a person that, quote unquote, plugs the hole. Every now and again, there is a need to provide some extra work, extra time from the outside, and that is what the floater does. A utility person, as I said, plugs the hole. So that's not exactly flexing. This is a person that when he or she sees a workstation that's falling behind, and you learn to do this by reading the line, meaning seeing the IP case beginning to get plugged. Then this person steps in and aids and assists. This is aiding and assisting. And what this person will do is by aiding and assisting, accelerating the delayed workstation. This is a very common practice at Toyota.
And by the way, what an operator does at Toyota when they finish early is typically they don't leave their station. In many cases, the takt time is quite short as well. They don't leave their station, but they're trained to take advantage of that little extra time they may have. They may have an extra 15 seconds, 30 seconds, a minute. And what they're trained to do is do some 5S, do something to make themselves useful, but they don't typically leave the station. So the floater would be the person that's actually moving, right, in that line.
Let me quickly. Sorry.
Go ahead.
Let me quickly answer Rosie's question. Looks like the way we explained bumping may have sounded very similar to actual flexing. Think in these terms, Rosie. If flexing, you move to an empty workstation. In bumping, you move to a full workstation, and the person that was there moves out to the next workstation. That's the main difference. And then again, bumping requires a higher level of complexity, a higher level of commitment. Hopefully that makes it clear. So if not, Rosie, shoot us an email and we can clarify a little more.
Yep. So in bumping, you're not waiting to the end of each cycle or completing all the work defined for that unit in front of you.
Exactly. In flexing, you are.
Yeah. In flexing, you are.
You start and finish. Right.
Yeah. Okay. Now, here's some of the other benefits that we could talk about related to flexing, or say over-designing or understaffing the line. Remember that in a lean environment, our goal is to build what the customer wants, not to build inventory. So ideally, we can build to customer orders. Can't always do that. If we have a consumer product and it has to be on the shelf, sometimes you're required to actually have some kind of forecast, building products that you haven't sold yet. But ideally, we like to have sold the product and are working off a backlog of orders. Now, if you don't have a large order backlog or very short lead time, for example, the example I like to give is eyeglasses. if you're a lab making lenses for eyeglasses, you don't have a whole lot of time to turn around a customer order, right? And grind the lenses and cut them and fit them in the frames. The customer is not willing to wait, and your competitors, are pretty fast as well. So what can happen in those environments, if you're not working off a large backlog or you have a very short lead time, is that you may not be able to build the same number of units every day, right? And you may design a line for some quantity, but you may actually not have that number of orders, or you may have a variation in the work content that makes it difficult to build the same number of units every day. Now, Toyota at least Toyota Material Handling, they try very hard to build the same number of units every day based on the design of the line. So whatever it is, whatever that takt time is, they try very hard to hit it. And if you're a worker on that line, you already know how many units you're going to be building today, because the line was designed for that volume, and that's how many they try to hit every day, even if it requires working overtime. Overtime is an expectation that is built into your contract, right, as a worker. But if you can't do that, then it might be very beneficial for you to be able to vary the output of the line without changing the line, right? Without redesigning, without recalculating takt time and recalculating resources and doing a whole new line design. The physical line doesn't change, but you can vary the output of it within limits. So that's what we're discussing here.
That's one of the key benefits of flexing, not just the productivity, but the ability to control the output. And it is linear. Flow lines are designed in a linear fashion. So if you decide 10 workstations for an output, 10 people for an output of 100, you take one person out, you will be at 90. But as the bottom bullet indicates, there is a limit to it. 50 to 100% of the line's capacity. That is the lower level, 50% of the capacity. You cannot build a line and then try to run it at 30% capacity, because at that point there will be so much flexing, it will become another form of waste.
Yeah, what's going to happen if you go below 50% is you're going to start. There's no law of the universe that says you can't do that. But what's going to start happening is people are going to be having to move longer distances, so more non-value added motion. And also, more likely, you're going to be outstripping people's ability to know how to do the work, right? You're going to be outstripping people's range of certification or job skills. If you're asking them to do too many stations outside of their primary station on either side. So 50% is a rule of thumb that we suggest. But within that, that's a lot of flexibility. From 50% of the line's designed output up to 100%. Now, can you go over 100%? Sure, if you work overtime, you can go over 100%. Or if you're building very easy products, you can go over 100%.
In a well-designed line, you need to think 100%, right?
Yeah. So that's a whole lot of flexibility, and if you have that need, if that's your kind of a manufacturing environment, this could be extremely powerful. Now, this only works if you can understaff the line and have people flex, right? How else would you do it? So if you're running less than 100% of the line, then you're going to have open workstations, and people are going to have to move based on these demand signals that we talked about earlier. But if you can achieve that, then that's extremely powerful. We used to call it a weapon, right, in your armory, a competitive weapon to do battle in the marketplace, right? You've got this resource, this tool, this production line that's extremely flexible in terms of producing what the customer wants, and that demand, that daily demand, can vary from one day to the next, simply based on your staffing. Nothing else changes. You don't change your material delivery plan. You don't change the number of workstations. You don't change where tooling is needed or tools are stored. Nothing changes except the number of people you have in there. So that's extremely powerful, right? Sounds good, right?
Yep. Probably one of the most powerful aspects of this. So here's the flexometer. All right.
Yeah, the famous.
50%. At 50%, you're in danger.
Oh, is that what that means? Oh, I see. Hey, that's pretty cool. So if you go over 50%, you're in the red zone.
Above 50%, you're good. At 50%,
yeah, so
you're in danger. Think about flexing too much. How do you like the flexometer? Way to go, huh?
Yeah, I like that. Yeah, I like that. Okay, it is possible to flex too much. Again, for the reasons we just discussed, right? Training, the two big risk factors, training and non-value added motion start going up. Okay, so here's the important point. All this flexing stuff is great, but it's based on a foundation of a good design, good line design. So it doesn't make sense to be talking about flexing if your actual production line wasn't engineered properly to begin with. Because although you can get some benefit out of it, really what you need to do is go back to basics and follow the line design roadmap that we've created and take a look at really designing the line properly to begin with. So there are a whole series of steps that you need to go through, including data collection and some calculations. This is really lean. You could think of this as lean industrial engineering.
This whole flexing thing is all predicated on a valid line design. Flexing is not a cure for a bad line design. That is not going to happen. You must start with a solid line.
Yeah. Okay, so one of the steps is you calculate resources per process, then you define workstations, balance. So critical point, and balance some more. Wow. Beating that one to death. So balance would be the allocation of work steps as even as possible. It's going to be extremely important. And then when we start talking about flexing groups is an important consideration. In other words, what are the limits? What are the logical groupings of people within that line that you want to train to move? So people understand the zone that they're going to work into. And this flexing group actually helps overcome this my workstation mentality that's very common as well. If you know you're part of this flexing group, then there's less of a tendency to think that this station is my station. Right? I'm going to put up pictures of the family and my dog, and I'm going to have my special little tools, and I don't want anyone else to mess with it. Because if you're talking about flexing, that mentality needs to go out the window, right? Other people are going to be working there. It needs to be interchangeable. So flexing groups is a good way to overcome that kind of thinking. And the number of operators that we're going to have is going to be, we need to look at this in a couple ways, but it's going to be rounded up. So we're going to calculate how many people, and at capacity, round up that number of operators. Let's take a look at how we would actually, assuming a valid line design, how we would work with the operators to get this flexing benefit. So here's our roadmap. The drill symbol this may be hard to see on your screen, I'm not sure. It's kind of small print. But the drill means there's a detailed roadmap that looks kind of like this. Underneath each of these phases or steps. So this is the highest level that we're talking about to create a line design. Gather data, develop standard work definitions, calculate resources, define stations, conceptual layout, etc. Test with simulation. So every one of these has a drill. That means there's a lot of detail underneath each of those steps.
In the calculation of resources and definition of workstations, that is when you start thinking, which are activities 4 and 5, that is where you start thinking about flexing. That's when you start defining flexing, because you calculate more workstations or you staff with fewer people and a number of workstations. You define the workstations with the ability to flex.
Yep. So we do have a process that we follow, right, to create a line design, lean style engineering. Now let's look at how this would work and how staffing would affect it. So if we have a calculation of number of workstations of 21. So we did the resource calculation, and we need 21 workstations. The resource calculation actually said 17.6 people, but because of rounding that may take place in various processes, we actually need 21 places where people can work. So physically, we have 21 workstations. And if our philosophy is to fully staff each of those workstations, then we're going to need 21 people. But we know that the productivity is not going to be optimum because the actual pure resource calculation was 17.6 people. But
so there will be wait time.
Yeah, there's going to be waiting. Some of those stations are not going to be fully occupied. And but if our philosophy is, hey, we can't have an open workstation with no one there, if that doesn't make sense to us, then you're going to need 21 people, right? And your productivity is going to be lower. On the other hand, if you can keep that same physical design, you still have the 21 workstations. That didn't change, but you can get people to flex or move within those flexing zones that we discussed, which could be within a process or it could be across processes. Then you don't have to round up to the number of workstations. You'd round up to the number of people that you actually need to do the work. And that would be 17.6 rounded up to 18 operators, right? So 18 people at capacity, right, are going to be running this line with 21 workstations. And you can see that's pretty close, right? 18 is pretty close to 21. And so you can appreciate that people are not going to be wandering, moving, flexing all the time. But when they need to, based on those signals we discussed, then some of these people are going to have to be moving at least part of the day, right, to cover those extra 3 workstations. Okay, now what does this give us? Just this alone gave us a 14.3% productivity increase over staffing a person at every workstation. Okay, so that's not too shabby. Yeah, just right there. And we're not even talking here about overcoming variability. We're just talking about basic staffing requirements. So that is pretty good. What are we doing? Thinking? Oh, we like it. Okay, that was 2 thumbs up. Now here's something else to realize when it comes to flexing, and this is based on a simulation model that we created, a real simple one. But just to show you what can happen, and the numbers you're seeing here were not made up or estimates; they were actual numbers that the simulation model created or generated. We had in this model 4 workstations, so 4 operators were fully staffed. 4 operators meant a person at every workstation. And when we ran the simulation model, we were getting 46 units per hour throughput. And so if you simply divide by the number of people, that's 11.5 units per person per hour. That's kind of a productivity measurement. And the productivity gain that's our baseline measurement. Now, if we pull a person out of that and have 3 people cover 4 stations, and remember, this line had variability of work content, different products. It was a mixed model line with harder units and easier units, et cetera. And that's what gave us the 46. So we take out 1 person and we run the line with 3. We have fewer people, so we don't really expect to get the same number of units out at the end of the day. And we see that it dropped from 46 to 41. Now, if we didn't really need 46, that's good. And if we over-designed this line so that our actual need was less than 46, that's even better. But with 3 operators, our productivity jumped up 19%. Why? Because there's less waiting, right, and less blockage. Because people are able to move to an open station and continue to add value. So the units per person jumped up to 13.7. And then if we run this 4 stations, 2 operators, again, our units per hour drops as expected from 46 to 41 to 30. But now the units per person jumped up to 15 units per hour per person. And the overall productivity gain, just purely looking at productivity, was a 30% productivity gain. So that's pretty amazing. And let me share with you a quick story. How are we doing on time? So we're a little bit over. I hope that's okay. We're getting close to the end here. It's 9:00. I have 9:03. But this is an informative story. I won't name the company, but they had a production line, and they fully staffed the line on the first shift, and then they partially staffed the line on the second shift. And when I was there taking a look at the first shift line running, I was there during the day, right, first shift, I noticed that there was actually what seemed to me quite a lot of waiting. For whatever reason, there's some kind of delay in the line, and operators were not flexing, and they were just waiting for the next unit to come along so they could get back to work. And I thought that was a little bit, room for improvement. Now, what they told me was the second shift, because they didn't have enough people, was running at something like 75% staffing. They just didn't have the people to fully staff the line. And I said, well, then what do people do? And they said, well, the operators have to move, right? They have to cover the stations that are not staffed. And I said, and what is the result then? And they said, well, strangely enough, the actual output or the throughput from the second shift is pretty similar to the output from the first shift. And I said, well, doesn't that tell you something? Maybe you should staff the first shift at 75% too. That would save you a lot of money. But somehow that, I don't think they took that recommendation to heart. But it just shows you, removing people and giving people room to move can make a big difference. And that was like an example right in their face of how that happens and why that happens. Right? Anything else, Gerard?
No, not that. I remember that story.
All right, so let's wrap it up. So we'll talk about what flexing is and what it isn't. So flexing is not. Gerard, why don't you share the story? Our experience with John Deere on flexing. Remember
actually, with this company that shall remain nameless and makes tractors where one of the colors is the primary color and the other one is a color made of blue and yellow. These folks, we had a bit of a hard time convincing them of the importance of flexing, and it was all about a misunderstanding. And the misunderstanding was the concern or the idea that flexing was people walking around looking for something to do, which it isn't. Flexing is based on rules, and the rules are the 3 flexing rules we teach that can be boiled down to a very simple full down, empty up. And if you learn the flexing rules from our classes, you will see is full down, empty up. Is triggered by demand signals, and that is you look at your IPK, you look at your workstation, and you make a decision as to where to go. Nobody has to tell you. So it is based on the demand signals. Flexing also widens your skills. You not only have to know one workstation, but you need to know at the very least one up and one down. So it increases the breadth of knowledge. It's a key strategy for improving productivity, improving flexibility, and it is very inexpensive. Now, of course, you have to be reasonable and understand that you will require training. There is that investment. But other than that, people are paid for 8.5 hours on the job, and 8.5 hours is what you get. You just get more production out of those 8.5 hours.
Yep. And let's not forget about the importance of communication and teamwork.
Absolutely. When you look at a line where you flex, you're not looking at an individual, you're looking at a team working together. And it is very important the manager that manages a team is not the manager that manages individuals. So it's very important to understand when to intervene and when to let the team take care of an issue. Someone that may not be pulling the wrong weight, someone that's not properly trained. If the team has the incentive to work as a team, they will make sure that people are brought up to speed. So the level of work and communication is actually leveled across all workstation and all people.
Yeah, and this raises the point that I think we won't get into now, but it's the point of what are your incentives? Like, do you have team-based incentives, bonus plan or something like that, or is it based on is it individually based or is it team-based? And it really needs to be team-based. if you want people to get excited about working together, working with their coworkers, and not competing with them. Right? And then, of course, flexing is a key strategy for improving throughput. Why? Because if you're adding value more than before, then your throughput's going to go up. Right? You're adding value more. That product is flowing better. Right? You're going to get more units at the end of the day. All right. What is flexing not? I think Gerard mentioned this a few minutes ago.
It will not fix a bad line design. A bad line design will be pain forever, will be Kaizen forever, and everything needs to start with a solid line design.
Yep. Same thing here. I mean, it's not going to fix.
I remember that was one of the concerns at one of our clients, opening the door to say, well, don't worry too much about balancing. Flexing will take care of it. No. You're not doing your job. You balance the line to the finest possible degree. Then you let flexing take care of natural variation.
Okay. You just said that, right? Not a replacement for balancing. Yeah. Not a barrier to incentive pay plans. Okay,
not at all. Much on the contrary. It helps with incentive pay plans.
Yeah. And, okay, it's not something that's necessarily natural. So people need to be trained.
Like, nobody was born knowing how to flex.
Yeah. Trained and practice it, right? Practice doing it. And the good news at the end of the day is it's really not that difficult. It's certainly.
Yeah, that's absolutely correct. Not that difficult.
All right. Not a way to look busy. Okay. Mm-hmm. So closing comments. The productivity gains, I don't know, other than if you're going from a bad line design to a new line design, a good line design, then probably you're also looking at great opportunities for productivity improvements. But beyond that, flexing, it seems to me, is like the lowest hanging fruit for a lot of companies. That's not really being embraced in a lot of cases. So they can be, single, double-digit improvements. The flexing group should have a group level incentive. So what you want to avoid is something that we hear all the time, which is operators saying, "Well, what are you telling me? You want me to do this other guy's job?" And we have to explain to them, no, you work as a team and you're all going to benefit, right? Because you have a group incentive. So if you can improve throughput, add value more, productivity goes up, all you guys are going to benefit. So you're not doing someone else's job. You're here the same number of hours per day as you were before. So also abolishing the my workstation mentality. I think we talked about that. And in general, do not overstaff. So our recommendation is plan to design the line and plan to run the line on a regular basis, not on an exception basis, on a regular basis with fewer operators than the number of workstations to take advantage of this. As your level of staffing goes up, the higher the level of staffing as a percentage, up to 100%, your productivity is going to be going down. So
a typical symptom of a supervisor with not enough experience is as soon as they see a problem with the balancing of the line, they think that adding more people will fix it. No, better balancing will fix it, not throw more people at it. And you will see the principle of diminishing marginal returns when you fully staff a line that was designed to have more stations than people.